Oops, got to go back to the beginning here. All right. Welcome, everybody. So we're doing something kind of a little different today, rather than a usual presentations that we've given on things like Akka.net and event sourcing, which we'll be doing some more of those later this year too. I had actually gotten asked to prepare a presentation for one of our customers here at Petabridge back in April on basically like how to leverage artificial intelligence tools like ChatGPT and GitHub Copilot in day-to-day use. They had seen me use it in a lot of my videos and a lot of our live conference calls together, and wanted me to put together a presentation for their team of 70 or 80 software developers. So I did that, and I thought, this might make for a good thing to share kind of outside of just that customer's use case. And so what this presentation is really kind of about is how I use these tools in my day-to-day workflow to actually do stuff, and to kind of show that, ChatGPT and GitHub Copilot aren't going to be automating away our jobs anytime soon. And I'll get into some of the reasons why that is. But in the grand scheme of things, they actually can help you be a lot more productive if you use them the right way and you are sufficiently skeptical about some of the outputs they can produce. These tools are far from perfect, but they do allow you to automate a lot of tedium out of the picture and allow a single software developer to express a much larger number of ideas more quickly and efficiently than they could before. And that's really what we want to focus on, is efficiency. So let's take a look at what we're going to cover today. We're going to talk a bit about GitHub Copilot. Now, one thing that's changed really since I gave this presentation originally back in April is Copilot Chat being available in your IDE, which does give you the ability to have much more of like a ChatGPT style conversational experience. So we'll talk a bit about that. And then the other thing we'll take a look at is ChatGPT 4 actually using like the web UI to go and do things behind the scenes. Personally, I use ChatGPT's web UI probably 30 times more than I use GitHub Copilot. Copilot's fine, but I don't like having to sit there and wait for it to do things inside my IDE. I kind of like to just go. And a lot of the problems that I've been having to solve more recently tend to involve a lot more things that are better suited for interactive prompting via ChatGPT. The other thing I like about it is that members of my team, I can share some of my prompts with them if we need to go and take a look at, let's say, various things that I'm working on. So for instance, lately, we've been rewriting a lot of Akka.net's documentation, and I've been using ChatGPT pretty heavily to generate Mermaid diagrams, showing execution flows and component diagrams and org charts and that type of stuff. That's been one of those things that's been useful to kind of socialize, where I can ask Gregorius or another member of our team, hey, does this diagram demonstrating, how actors are organized, does that look like it makes sense to someone who's brand new to it? So that's kind of one of the things that's been useful for. So we're going to start by talking a bit about Copilot, since that's kind of integrated directly into the tools that we use every day. I'll also show Copilot Chat a little bit. Next, we'll talk a bit about ChatGPT and how to use it to go and generate complete syntax for things like, I use it all the time for generating GitHub Actions YAML. I don't think there's a huge amount of value. One thing that's one debate that people have had about these AI-powered tools is this going to introduce atrophy in our brains and in our skill sets, the same way that spell checking has made it so our natural ability to spell things has actually diminished over time. And that's actually like provable. There's like scientific papers that point that. And I know experientially that's definitely been the case for me. I'm probably worse at spelling words these days than I was in high school. So there's been some discussion as to whether AI tools will contribute to that as well. Here's my take on it. You probably shouldn't rely on AI to generate things that are essential to your job, such as knowing how to model your domain or knowing how to reason about, let's say, failure modes and distributed systems, that type of stuff. But I could give zero craps about generating GitHub Actions. I don't really care about learning the intricacies of YAML. That's not something that's ever going to be all that interesting to me, and it's fairly ancillary to what it is I need to do. As long as I have a way of organizing my thoughts and being able to tell Copilot, here's what you should do, and if I run into trouble, I can debug it later, then I'm fine. So that's kind of one of the things I tend to use ChatGPT for quite a bit, is helping me write things that are somewhat ancillary, not primary to my job. So shell scripts also fall in that category. The next area where ChatGPT can be super useful is writing things like Roslyn analyzers. If you're an Akadonit user, most of the analyzer rules we've introduced since January and all the new versions of Akka.net, those were all initially written using a stub generated from ChatGPT. And the reason for this is that Roslyn syntax, involves navigating around the syntax tree, and it's a very sort of like intense form of meta programming. Learning how to write that from scratch is probably useful in the grand scheme of things, but it's not necessarily the best ROI in my time. As long as I could generate something that gets, let's say, 70% of the way there with Roslyn or with ChatGPT, and I can kind of figure out how to productionize it and professionalize it, that's a good enough balance for me to be happy with it. So that's exactly what we've done with Roslyn analyzers. The other thing that we've used ChatGPT for quite heavily is either writing documentation or trying to reverse engineer existing code. So for instance, you'll see some examples of us trying to debug some distributed systems issues and have ChatGPT try to interpret log files that we get back from users or that we generate ourselves. That's one thing we'll use it for. I use ChatGPT very heavily to generate Mermaid diagrams. Again, I know how to draw a flowchart. I'm not necessarily all that interested in learning how to use Mermaid syntax to do it. I'll learn it if I need to go and refine one of the diagrams that ChatGPT generates for me initially. But writing stuff from the ground up, I don't see this being a huge value add for my day-to-day existence here. The other thing that I found ChatGPT to be surprisingly useful for is reverse engineering existing code. I'm going to use one particularly complex example from the Akka.net project itself, where we have some old code that was written by a contributor who's no longer active with the project, and I've suspected that this code could probably use some housekeeping and be improved. I asked ChatGPT, go ahead and render a state machine diagram for me explaining what this code does, and it was actually spot on. It would have taken me probably an hour to go ahead and come up with that myself, and ChatGPT knocked it out in about 30 seconds. So that's pretty impressive. We'll take a look at that. So let's start by taking a look at CoPilot. The way I've kind of phrased this to my team and to some of my customers who've asked about it is that what CoPilot's really good at doing is automating Tedium while you're in the course of authoring it. So this may no longer be true with Copilot Chat now being a thing. I'll show that in just a moment, but prompting functionality is super limited to some extent and not easy to iterate. I found that when you're using the sort of normal prompting syntax for Copilot, it can get stuck into a loop where it's like recursively authoring comments about what it should be generating rather than generating the thing the comment describes. So you can kind of end up, with a lot of, let's say, false starts in here. It's very convenient. I don't have to leave the IDE to take advantage of it. That's probably Copilot's biggest superpower, is it's right there meeting you in the space where you're doing your work. It's really good at generating highly repetitive formula-driven code. Copilot does learn from some of the other patterns that you use throughout your application, and it's pretty good at being able to follow them. So for instance, in my unit tests, I do a lot of this sort of arrange, act, assert stuff. Copilot's pretty good at being able to follow that right out of the gate. I'm going to use a little example from Turbo MQTT in just a moment to show you how we can try to use Copilot to generate some unit tests for validating our packet parsing system. It's also very good at generating simple self-contained formulas. One of the first things I used Copilot for was writing an Akka.cluster simulator for a product that we've been working on, where we're trying to visualize what's happening inside the cluster. A lot of that is all very time-driven type work, and we want to be able to go and organize data points into time series. Copilot actually came up with some pretty robust, simple formulas for being able to do that sort of time-based ordering real easily, organizing all these different activities basically by time cohort, where I could arbitrarily say this cohort should be 10 seconds long or 30 seconds long or 5 seconds long. And Copilot was able to generate a function that could basically very easily express that for me. Surprisingly simple. So yeah, I use that example here. So let's go ahead and take a look at a little Copilot demo and talk a bit about how we're going to use it. Let me pull up Turbo MQTT here. So Turbo MQTT, if you haven't seen it, this is a implementation of the MQTT protocol. This is like a popular IoT system. We've got a lot of customers that are doing industrial automation or working in like the energy space where the MQTT gets used very heavily there. I wasn't super happy with how performant the other MQTT solutions in .NET were, so I wrote my own on top of Akka Streams. So what we're going to take a look at here is in our test suite, we have, let's see, these are our tests for validating specific types of packets. There's like a family of maybe a dozen different packets that all exist inside Turbo MQTT. These were all originally generated, by the way, using ChatGPT. So for instance, I wrote a prompt, create a size estimator spec for the MQTT 3.1.1. That's the version of the protocol that we're implementing here, con-ac packet. And it'll go ahead and generate a little stub using the same formula that's seen me use before. And then I had to do that for the MQTT5 packet type as well, where all that it's really changing was it figured out that this enum needed to be a little different down here. And that's basically all that we kind of expected. I also had to manually specify what packet size we wanted to use. Let's do something a little bit more interesting and generate a new packet type from scratch. Let's go to protocol. Let's go to our MQTT 3.1 decoder spec. And let's see. These are for testing more interesting things like partial frames and validating parsing headers of packets. Let's go ahead and define a little spec. Let's go ahead and do one down here. And see, am I outside of my test method? Let me close that. Yes, I am. Okay. We'll go ahead and do generate a test method that can handle, let's see, a con ac publish, actually con ac subscribe ac, and a publish packet, all in the same byte array. Let's see what it comes up with. All right, so that's not an encouraging sign that it's kind of coming up with an FS check spec for this. I was hoping for just a simple X unit test, but you know what? If it's able to use FS check for that, more power to it. All right, so it didn't quite compile. So let me go ahead and open up GitHub Copilot Chat. And let me go and paste my original prompt into it. See what this comes up with. And by the way, I think this is probably a lot easier to use. Yeah, it's coming up with the exact same thing that the normal comment-based prompting approach is doing. All right, so I'm going to go ahead and give it a suggestion in just a minute here once it's done dramatically spelling all of that out. Oh, this is cool. It can show me which references it's using. It's referencing the last few tests I looked at, the con-ac packet, the TCP transport actor, the MQTT 3.1.1 decoder specs, and the packet encoding test helper. Instead of generating a property-based test using FSCheck, could you just create a simple test case using plain XUnit facts instead? Let's see what it comes up with on this next iteration here. All right. That's looking encouraging. It's generating a packet. It's got to assign it an ID. It's one of the requirements that publish packets have. They have to have an ID. Let's go ahead and copy this, and I'll paste it over the old test. All right, and let me go ahead and dock Copilot Chat real quick. I think it's a sub-ac packet, not subscribe ac. There we go. Buffer 1, encode packet only, buffer 2. So it looks like it didn't quite get all of the byte copying stuff done correctly. So I'll need to go and fix that, and I'll need to go and fix this down here. But this looks like otherwise, Copilot did a pretty reasonable job of being able to do what I wanted after I was able to go ahead and give it a little bit of feedback. Now, bear in mind, I'm using JetBrains Writer. I'm not using Visual Studio, but GitHub Copilot and Copilot Chat, this is also available in Visual Studio too. It should be, not sure exactly where it would be on the UI, but I imagine kind of a similar little tool strip maybe up top here is where it would be. So this gives us kind of a little bit more of an interactive prompting experience. And an important thing to note is that it still gave us something that doesn't fundamentally compile. That is going to happen when we're using these sort of generative AI programs to write code for us. They don't really have an internal sense of, let's say, like lexical or symbolic like correctness inside of them. They're basically just aping text they have in their large language model and coming up with things that seem probably like it would make sense. So a good example, this is code right here, I believe, is assuming that this is a type of byte, sort of with the normal array syntax here. Whereas what we're actually returning from the packet encoding is, if I get rid of the implicit variable here, this is actually memory byte. ChatGPT doesn't understand that what this is returning here isn't actually the same as the type that's expected here. It has no internal sense of that type of symbolic equality. And that's one of the things you have to be mindful of. This is why I don't really think in their current iteration, these tools are going to be able to write super complex pieces of code on their own. They're just missing that sort of, let's say, static typing awareness that would be necessary to produce things that can even compile, let alone run correctly. Let's see. Question here from Chris Rayner. Which GitHub Copilot subscription version are you using? I'm using the free subscription for open source creators. So I'm not totally sure off the top of my head. Maybe it'll say, if I look this up here, Copilot, let's take a look. Copilot chat. Well, not totally sure off the top of my head. I just upgraded all the most recent plugins the other day. Let me see if I can take a look at my help bar. Help. Let's see. I guess maybe it's in tools down here. Settings. Plugins. I am using, looks like the version of the plugin that I'm using is 1.5.6.5692 is what I'm using. And there's an update available I haven't upgraded to yet. But yeah, that's currently what I'm using. And I think, not totally sure when it snuck in the Copilot chat, but that happened pretty recently, within the past couple of months they did that. All right, now let's go ahead and move on to basically talking a bit about using ChatGPT. Generating GitHub Actions. I have been doing an enormous amount of CI/CD work lately on a bunch of different projects, and GitHub Actions are one of those things where it's like, I've used YAML for doing Azure DevOps for a long time, and GitHub Actions syntax is similar but different. I don't see a lot of business value in sitting down and trying to get like a GitHub Actions certification. Like, that's not going to do anything for me. So what I do instead typically is I'll go ahead and run a prompt like this. Please update this GitHub Actions script such that we're only running on Ubuntu latest and only execute .NET tests using .NET 8 as the framework. For Windows, we shouldn't specify a framework version at all. Oh yeah, I remember why we did this now. We had an issue on Linux where we had a project that was dual targeting .NET Framework and .NET Core, and the .NET Framework stuff basically doesn't compile. You get that sort of weird duplicate NuGet package reference for stuff that's in the base class library, things like system.valuetuple or system.bcl.iasync enumerable. That's what we were trying to avoid here. So if I go to my browser, let's see, where is my little browser workflow? I'm going to go ahead and paste in my snippet from my presentation here. Let me go and copy this. Okay, and all right, well, looks like it's not going to let me do that. Just a second here. Yeah, let me go ahead and make that a hyperlink. Here's what I'll do. I'm going to go ahead and end my show real quick, and I'm just going to grab this from down here. So it'll quote just work. Okay. So I'm going to go and pull up an old chat session that I had here, where I had an existing GitHub Actions file that I pasted in, and it went ahead and wrote out the updated GitHub Actions script for me. And basically everything was more or less correct. But then I pointed out that on Windows, we had this parser error with the YAML here. And eventually it gave me the right outcome. And this is now what we use in production for this particular project. So over a couple of iterations here, we eventually did get to the right conclusion. A lot of my, you can see all of my most recent prompts right here where I'm Let's see if I'm doing a lot of Kubernetes YAML. Oh, here we go. Ensure GitHub Actions continues regardless of whether or not this step fails. This is one I probably could have looked up, but I didn't really care. We're trying to delete a whole bunch of experimental Kubernetes namespaces from a Kubernetes cluster GitHub Actions is authenticated against. I say, I don't care if these namespaces really exist or not. I just want them deleted regardless. So we start in a blank slate each time. I can go ahead and prompt ChatGPT to do that. I probably have hundreds of GitHub Actions and Azure DevOps ChatGPT examples. It's great for doing that, works pretty well. And generally speaking, it's usually gotten me to the right answer. And it's pretty good at being able to come up with things that seem fairly like simple in terms of the types of scripts that it comes up with. So definitely strongly encourage people to use prompting for trying to get their YAML problems fixed when it comes to working with automated CI/CD stuff. Now, a couple of reminders. This is probably all stuff that you've all heard about if you've taken a look at the AI space. ChatGPT can get obvious things wrong. So you saw, for instance, we had that issue where the code that it produced, ChatGPT is fundamentally what's powering CoPilot, by the way. But we saw an example of where it was producing incorrect syntax that couldn't even compile. But ChatGPT can also get really subtle things wrong as well, things that you wouldn't necessarily notice because the program compiles. A good example of this is that when we're writing Roslyn analyzers, one of the things that ChatGPT will frequently do is it'll use lexical equality to determine that two things are the same, i.e., that the fully qualified type name, the actual string representation of it, matches in both places. That's a super inefficient way to write a Roslyn analyzer, and it will result in visible lag occurring when someone's analyzing a pretty large solution. What you want to do instead is use symbolic equality, which is looking at the loaded type from the assembly and making sure that these two types are the same thing. That's actually a much faster way of doing it and takes a tiny fraction of the resources that this does. And it's also much less likely to break in terms of basically the analyzer ceasing to function at some point in the future here. Let's see. Next, we want to talk a little bit about generating GitHub Actions. I think this was my example from earlier. Another example of using ChatGPT that I'm a big fan of is I do a lot of cross-platform work. That's kind of the nature of us maintaining big open source projects. So we do a lot of things with PowerShell, and we do a lot of things with batch files. But then we also have to do a lot of stuff with Linux under the covers. So in one case here, let's see if I can find my actual example for this. I basically asked it to convert an MS-DOS script into a bash file. I needed to move some of the work that this was doing from Windows to Linux. And if I'm not mistaken, this was for launching one of our, this is what this was for. This was for launching one of our Akka.NET code samples. So this was spinning up basically a little self-contained SQL Server Docker image container that had all of our tables we need for Akka.persistence already kind of pre-initialized in it. And I needed to get this moved to Bash, so that way people who are running these samples on OS X or on Linux could get the same outcome, basically. And it was able to do this quite successfully out of the gates. Let's see, added one additional thing I left off of the initial script. That's what this is for. I had to apply some entity framework migrations afterwards. And it was able to go ahead and add that to the very end of the existing file. And I think we still use this today. In fact, I'm pretty sure this is the script that we use on, if I pull this up here. If you saw our Blazor webinar we did last month, I'm 99% sure this script you saw me prompt right here is startdependencies.sh. I'm pretty sure that's what this script is under the covers. Let's see. It is, but we did get rid of the need to run entity framework on it. So yeah, that's what this script was designed to do. Allow us to go ahead and apply the entity framework update and make sure the database was fully initialized before we started using it. Again, another pretty good example of being able to leverage ChatGPT's functionality. It's not that important for you to know the exact syntax for how to use Bash or how to use YAML. Like, it's great to kind of get a sense for those things so you could spot when ChatGPT is doing something weird or doing something that's wrong. So it's enough to know just enough to be able to call BS on ChatGPT. but you don't necessarily want to be in the business of learning all of the ornate syntax that comes into running, a sed command for evaluating a file to do a string replacement. Or you don't necessarily want to learn how to go ahead and do required parameters, or you don't necessarily want to learn the syntax for determining whether or not the administrator is executing the script with sudo permissions versus non-sudo permissions. Those are things that you should feel perfectly comfortable saying, hey, I need to make sure this script only runs when the user is running as a sudo user, when they've elevated their permission in bash. It'll go ahead and generate a little snippet you can just stick at the top of your bash script, and that'll work fine. This is like a great way to go ahead and get some value out of ChatGPT at fairly low risk. Now, the more fun and interesting stuff is when we get into writing more complicated pieces of machinery like Roslyn analyzers. Roslyn's syntax is inherently pretty difficult to kind of grok when you first look at it, unless you're someone who spends a lot of time thinking about things like abstract syntax trees and lexers and parsers and that type of stuff. So what I did here was I used Roslyn to help write one of the very first analyzer rules we included in Akka analyzers, which was to make sure that users are not manually handling messages that are automatically handled by Akka.net. And the reason why we want to do that is basically just for performance reasons. It's one less case in a switch statement that needs to be evaluated every time traffic passes through the sharding system. And the sharding system is a pretty high traffic area in most applications. So let me go ahead and pull this up real quick. Unable to load conversation. Oh no. Well, maybe that is out of the picture here. So you know what I'm going to go ahead and do instead? We're going to, just like Bill O'Reilly, we're going to do it live. I would like you to help me write a Roslyn analyzer. In fact, I had a suggestion the other day in chat for a good Roslyn analyzer rule. I would like you to help write a Roslyn analyzer for Akka.net applications. If a user is executing an awaitable task inside an actor's receive async or command async in the case of Akka.persistence methods, we should make sure the user has not set configure await false, because otherwise this might break the ability for the actor's continuation tasks to run on its context. All right, let's go ahead and see what it comes up with. That's not necessary, but that's okay. This is what we really care about, the diagnostic. All right, perfect. And this is giving me exactly one of the things that I'm looking for. This is wrong, and this is wrong, but that's okay. Okay. So this is, if we take a look at Akka analyzers real quick, and I pull up some of our actual real analyzer rules that we use. Let's go ahead and grab analyzer, Akka analyzers. And if I pull up, let's take a look at the analyzer rule in question. I think it's under, let's see, which one of these projects is it actually? Akka analyzers. Well, there we go. If I take a look at Akka 1000 and we take a look at, should not use receive async without async lambda. There we go. Another kind of similar rule looking at one of the same parts of Akka.net that this one is. So we have here this sort of base class for Akka diagnostic analyzer, and this base class has a lot of the stuff that is being rendered. Let me close this. Has a lot of the same stuff that's being rendered up here, which is this sort of setting up the diagnostic analyzer and the initialization. All that stuff's already kind of being handled. But the analyze compilation method is the thing that we really care about. Analyze syntax node, analyze compilation. So one of the things that we're looking at here is you'll notice we have this extension method is receive async invocation right there. And in fact, if I go down to utility and I go to, let's see, one of these things should have it. Maybe it's core Akka core context. It's under actor. Yeah, we'll probably have it somewhere in here someplace where we have basically that extension method defined. But that extension method, if I go back to it, that extension method is performing symbolic equality. It's using the types defined by the actual .NET runtime and by the Akka.NET library to say, this is the method signature that we are looking for and that we are interested in analyzing. If this isn't the method signature that we're looking for, we're going to go ahead and return. And by the way, this method can also analyze things like derived base classes. It can go ahead and find, let's say, receive async invocations that are implemented on base classes and that type of stuff. What ChatGPT has done right here is exactly what I was kind of warning about, which is it's taking a look at the name of the member access expression on a function, and it's saying, is the name of that member configure await? This is what we mean by lexical equality. It's checking to see if the name of this method matches the thing we look for. It's not really looking to see, is this the system.tasks or system.threading.tasks.configure await, one of the base methods there. That's one of the reasons why we got to kind of be a little skeptical about it. But if we take a look at the inner argument expression here, we can see, did someone pass in a false literal expression right there? Okay. If they did pass in a false literal, and again, we're using lexical equality instead of symbolic equality here. If it's receive async or command async, then we're going to go ahead and report a diagnostic error here. So there's a number of things that we can improve upon here. Using lexical equality is one example. Another example is making sure we're filtering by the type of class where this method's being called. Make sure that this is happening inside one of the Akka.NET actor base classes. That'll make sure that we don't scan nearly as much content if we do it that way. So that'll help make this analyzer more performant if we do that. So this is a case where the bones of this analyzer are actually correct from a technical perspective, but the issue is that it's just not optimized, and it's also not using the best technique for evaluating whether or not two things are the same type of method and object anymore. And so we have to kind of apply a little bit of skepticism to what ChatGPT produces, and we got to clean it up. One of the other advantages to kind of fitting some of ChatGPT's code into our own framework is we already have some tooling built around being able to go ahead and load those symbols and perform symbolic equality right off the bat. So we know that we're given kind of an incomplete product from ChatGPT, and therefore we're going to take responsibility to go and clean it up later. But that's kind of one of the things you want to bear in mind when you're using these tools, is they are not perfect. They need to be brushed up a little bit. Let's see. Question from Avi Levin. If you're using CoPilot Chat, does it use lexical equality less often in favor of what I can find in your code base? That is a fantastic question. And you know what? We will go ahead and find the example to that right now. Let me go ahead and load. If I can pull this up here, let me go to Akka Analyzers, and we'll grab the solution file and see what happens. Yeah, this would be a big argument in favor of using CoPilot over ChatGPT if that's the case. I don't know if I'm using the most recent version of Akka Analyzers because I haven't synced it in a little while on this computer, but I think it should be okay. All right. So then Avi says again, for things in the framework, can you tell it to just use symbolic equality if you see lexical equality? Let's find out. The answer to that question, I suspect, is it'll try, but it probably will get it wrong. And the reason is you need some place to kind of store those symbol definitions somewhere. And that's not something that is natively necessarily part of the serializer or not a part of the analyzer. In our case, we're using, like if I take a look at the context class right here, if I take a look at Akka core context, we basically have these sort of classes right here that get lazily loaded that have these property symbols on them. This is something that maybe CoPilot Chat would be better at doing. All right, so let's go to Akka 1000 and let's go ahead and do CoPilot Chat. Pull this out a little bit. And let me grab my exact same prompt from before. Just go and copy and paste that. All right, let's go ahead and paste this in here. Please use, actually, let's see if it just does everything right on the first try. I'll go ahead and mention something about lexical equality later. And maybe I can give it another hint, like, let's go ahead and grab this. All right, it's cranking away here. Yeah, another thing I'd probably change is it's looking at invocation expressions. I would probably try to register the syntax node. I mean, I guess that's probably okay. I'd probably try to register it to look like, if we take a look here, what are some best practices for writing Roslyn analyzers? That's interesting. Oh, whoops. Nope, I'm good. Don't need to do that. Can you rewrite this to use R instead? Let's go ahead and try to get it to use our actual base class correctly this time. That'll kind of help cut down the amount of work we have to do. All right, that's looking better. It's grabbing the wrong rule descriptor. So that's another thing I'll have to tell it to do. This is for another rule that we have that exists internally. So it's probably grabbing that, yeah, from the file I'm looking at right now. It's grabbing the semantic model. It's grabbing the Akka core. And look at this. It is actually trying to perform symbolic equality now, using some of our other base code to do it. I'm pretty sure it's doing it on the wrong thing, so it's still not quite right. But this is definitely a step in the right direction. Yeah, it looks like you just copied the Let's go ahead and give it one more shot here and see how it does. We have to yell at ChatGPT and chide it for also basically Stack Overflowing code, just doing a copy and paste. Let's see. Because basically, here's what I would say about this before is that it did a better job of trying to follow the pattern that we're in, but actually this code, in terms of, let's say, doing things like graceful stop should not be awaited, it's looking at the wrong methods on here. It's looking at just graceful stop, which we don't care about, because that's handled by another analyzer. So let's take a look at this. Semantic model. It's looking for, let's see, an awaiter expression. Okay, cool. It's looking for specifically just await expressions. Is that a thing? Let's take a look at that. Syntax kind. Oh my gosh, well, that's a new thing I didn't know, that it can look specifically at just await expressions. Well, that is a huge a point in Copilot's favor right there. That's much more efficient than trying to write a rule to look for, you know, output a bunch of other arbitrary things and blah, blah, blah. Being able to basically just say, look for just await expressions and then check to see if there's a configure await there, that's much better. So I might end up actually using some of this code today. But the point of this little section is that Copilot can actually get you started working on things that are pretty complicated. Roslyn analyzers are not a thing that's normally in my wheelhouse. But I know enough to be able to go ahead and basically spot check if Roslyn is, or if Copilot's producing the right things. And I think that with a little bit of iterative prompting here, we can probably get it into a state where it's like 60 to 80% usable, and the last 20% will be for us to clean up. And that's a lot more efficient than just writing it by hand. Here in the course of like 10 minutes, I've gotten a lot further with that than I could have in 2 hours on my own, probably. Now, the next thing, let's see if this actually pulls up. It may not. I tested all these the other day, but yeah, this pulled up, but the other ones didn't. Go figure. If I go back to CoPilot here, we're trying to go ahead and let's see, what was I trying to fix when we did this? Oh, I remember now. We were trying to fix a bug with potentially restructuring the way some of Akka Stream's built-in packet parsing stages work. We were basically trying to move from using byte string, which uses just like array segments under the covers, to trying to actually use system.memory. And we were running into problems where basically our packets were getting fragmented in kind of a weird way. I should get this. Instead, I was getting this, which indicates the presence of like an n+1 error somewhere inside our system. So what do we need to do to fix, what do we need to do to go ahead and fix this? Well, I'll pull up that prompt again real quick. But the basic gist of this, if I scroll all the way up to the top, I've got our refactored code, and I talked about what this does here. I won't bore you with all the details of that. It's quite a substantial piece of code, though. It was able to go ahead and kind of analyze what it's doing and what it's compacting. I showed it the unit test in the next prompt. One of the things you do have to be mindful of is there are character limits to basically how much input you can give ChatGPT or Copilot all in one go. You might have to kind of feed it data on multiple successive iterations here. That's kind of what some of those auto agent frameworks are kind of aimed at doing. I normally, these days, I think the token limit is, by the tokens don't necessarily correlate directly to like the number of characters. It's kind of defined in a little bit more nebulous way than that. It's the number of tokens that the actual LLM features extract from the text that you give it. There are ways of computing that by hitting the OpenAI web APIs to evaluate that, but it does scale pretty much linearly with the amount of text you're sending it. So it's not one for one, the number of characters or even the number of words. The way it extracts tokens can vary a bit. So I don't have a totally 100% deterministic way of doing it, but nevertheless, the code files that we're passing to it here are not small, and it's still able to handle those reasonably well. So as part of my iterative prompting here, we're trying a whole bunch of different approaches for figuring out what does and doesn't work. It's generating new code for me to try. I drop this into the test. At one point, I tell it we have to start over. The new, like basically, we're kind of barking up the wrong tree here. This code isn't working anymore. So we go and we start back over. I go and give it basically another unit test that rules out one of the problems we came up with. And the long and the short of it, I think eventually I did end up getting to a solution with this particular code, but this was hours of me going back and forth with it to try to find the problem. And eventually it came down to a really stupid off by one error in the way we were basically selecting slices coming off of spans is what it boiled down to. So I was eventually able to find it by bouncing a bunch of ideas with ChatGPT's help. So it's not going to give you necessarily concrete, I have definitely found the bug with your code type responses, but it definitely sent me in the right direction eventually. And I was able to find the bug, and it was able to kind of help work through the process of elimination sequence with me as well. So that's something that's very useful for like rubber ducking and getting some feedback and getting some ideas and how to address challenging problems. The one issue with this approach in debugging though, is that ChatGPT is probably not going to be able to help you solve like a distributed systems issue where there's multiple participants all involved in some operation. This bug had to be self-contained enough that I could kind of feed it most of the context it would need to troubleshoot the issue in one go, if you want to do this type of sort of precise debugging. We have had cases where we fed in logs from our multi-node test runner or logs from like a customer's environment to try to understand what could an Akka.NET cluster have done to produce this situation? And it's given us actually some pretty reasonable analyses of that too. Let's see. Next thing I kind of wanted to touch in on, oh yeah, this one's cool, diagramming code. So this piece of code, if you're an Akka.NET user, maybe you've heard of Akka.io before. Akka.io is basically our system for being able to do like handling of TCP and UDP connections. It's not used for, let's say, running Akka.remote connectivity, but it's used for things like Petabridge.command, for instance, our command line client for working with Akka.NET uses Akka.io for being able to communicate over a TCP channel between the command line client and the server itself. It's also used for a lot of IoT stuff out there. So I've done a ton of work over the years with TCP. That's definitely one of my wheelhouses. And I took a look at the TCP connection base class actor, and I thought this seems tremendously complicated. And it's probably one of the reasons why Akka.io has a lower bit rate than it probably should, knowing everything we know about it. So I fed it the entire source code for this class. And this class is, if I pulled it up, let's see. Got the Akka.net source code here. This is in the Akka.io folder, and it should be TCP connection. All right. So I fed it this entire file, which is, we'll call it 1,100 lines long, roughly. I fed this copied and pasted this entire file and said, draw me a diagram of how this thing works. Draw me a state machine diagram. Yeah, create a Mermaid.js diagram to represent the life cycle of the TCP connection actor from the provided Akka.net source code is basically what I said. And it started generating that, generated all the stages, created a state machine diagram, and I went ahead and I rendered it using Mermaid's live editor, and this is what it came up with. I went ahead and reviewed the code myself after this, and this is totally correct. This is exactly how this code actually works. This was with ChatGPT 4. I see there's a question here in chat. Are there any substantial differences between the responses of ChatGPT 4 and 4 not, the new version that it came out with? To be honest, I haven't really noticed any. There's definitely really significant differences between GPT 3.5 and GPT 4. I've noticed big ones there, but the new GPT 4.5 model that came out, it's kind of more of the same, is more or less what I've noticed. The one thing I will say though is at some point, actually there is one significant difference. The version of Mermaid syntax that 4.0 knows how to write is definitely a lot newer than the one that 4.5 knew how to use. So it's been better at generating newer diagram types. So for instance, I've been using it to do things like component diagrams. It's been a lot better at doing some of that than the older versions were. Let's see. So yeah, diagramming code. This is really useful to help me kind of reverse engineer what's going on. Again, kind of the constraint here is you're not going to be able to feed an entire Visual Studio solution into this thing. You're more or less limited to what you can stick in a handful of code files potentially. So the size of the solution you're trying to analyze does make a bit of a difference here. Maybe you could iteratively feed in an entire solution via, let's say, gradually bringing the tokens in. That would take a little while to do, and I'm not confident you would get necessarily a pretty good result from doing that. The bigger the thing you try to get it to do, the weaker a solution it might give you. Whereas trying to make everything fairly self-contained like this, ChatGPT's got a lot of experience basically analyzing, let's say, Akka code and Akka.net code. So being able to go and produce a state machine diagram for it as well within its wheelhouse, trying to analyze a 200 solution Visual Studio file, good luck. It's probably not going to be able to do that very well. ChatGPT refactoring, another thing that I've done. I needed to go and refactor one piece of code inside Turbo MQTT to basically deal with a variable length encoding field. And the piece of code I was looking at for doing this was originally built using IEnumerables. I wanted to change it to use read-only memory instead. So let me paste that sample in. And let's see. Yeah, so this was a piece of code here. I think this was from Akka Streams, I think is where we had this before. And so I said, look, this thing uses this little IEnumerator, and this code kind of sucks to work with. I'm not a huge fan of it. Can we rewrite this to just give me a read-only memory object instead? And so I pasted this in. It went ahead and transformed it. And let's see. If I'm not mistaken, this code actually did work correctly on the first try. The reason why ChatGPT can do this, by the way, is because things like Little Indian encoding are one of those things that it has thousands of code samples for across lots of different languages, and the sort of the corpus of work that ChatGPT has to be trained on for this is pretty big. That's why it can get something like this right pretty much in the first try. We also decided to have it do big endian encoding while I was at it. And yeah, I'm pretty sure these are both Akka Streams things that we did down here. And I'm pretty sure both of these pieces of code actually worked on the first try right out of the gate, which is great. helpful for me. I had unit tests to go and validate that, so I didn't need to just take ChatGPT's word for it. I could actually go and prove it inside our test suite. But this was a big improvement for us for some of the performance work we were trying to do in Akka Streams. So refactoring existing code is something that it's capable of doing. When most people use like ChatGPT, they're primarily using it for generating new code. Being able to go and have it refactor something that's been around for a long time, this function was nearly 10 years old, is also a huge value add. Definitely encourage you to try it for that as well. Let's see, and I think we're getting close towards the end of the line here. This was another good one. I was analyzing the same TCP code that we drew the Mermaid diagram of before. And what I was trying to do here, if we scroll up to the top, was basically we had this fairly complicated actor base class for dealing with TCP. Actually, wait a minute. This is the Mermaid stuff. Oh yeah, derp. Sorry, I did this later in the same file. After it had analyzed the design of the actor and generated that state machine diagram for me, I asked it how it considers simplifying some of the state. You gotta love that for refactoring a class for handling a simple TCP connection, ChatGPT suggested using microservices down here. Clearly, it follows a lot of popular .NET content creators on YouTube. That's where it probably came up with that idea. But what I really was asking for is the queue we use for managing writes today is unnecessarily complicated. I would like you to try to give me a simpler implementation of it. What might that look like? It came up with a little design down here. And I think I took a look at this and came to the conclusion that this is actually doesn't meet some of the thread safety requirements that we have. So it wasn't appropriate for us to use. And I kind of was mostly just kicking the tires on saying what we could do to fix this area here. I wasn't all that invested in trying to go and fix it just this minute. But it did give me some ideas for things we could do to try to improve performance and try to simplify the design of this actor with the hope of making it easier for us to do things like incorporate new system.memory method calls in a few different places there. So in addition to like trying to refactor simple methods, it also can come up with some designs for, let's say, restructuring a class, restructuring the flow of execution of a program. And these are all, let's say, value-added things. Again, you don't have to do everything ChatGPT suggests, but using it to go to kind of get inspiration and get some ideas for what are some avenues we can explore to solve a concrete, describable problem, it can give you some pretty good suggestions for that. And if I came down to this old prompt, let's say I upgrade it to the newest model, say, let's revisit the design of these simplified write queue. Can you generate another example of how we might incorporate that into our TCP connection base actor? Looks like it's coming up with the exact same data structure that we had before, and maybe it's going to try to actually incorporate that into the design of the actor. Oh yeah, there we go. Cool. Well, I'll have to go and double check that. This is going to be quite a bit of work to validate, but still, nonetheless, a super useful way of trying to go ahead and leverage ChatGPT under the covers. So that's what I've got for you today in terms of some of the examples of the ways that we try to use it. You know, we're not an AI products company. I'm not here to go ahead and sell you an ebook or anything on that, but we just thought it'd be useful to kind of put out there some ways in which we use it to solve some of the systems programming issues that we do and some of the other ways that we use it inside our company. As you can see here, I use the tool pretty heavily. Lately, I've been using it to generate documentation and things like that. We're rewriting the Akka.NET doc website right now, so that figures. And I've also been using it to do things like generate Prometheus queries for dashboards and do all that sort of stuff. Let's see, a couple of questions that I'm going to address here. Where do I download the slides for this? I will make the slides available on our SlideShare, and I think I'll attach this to the email that's going to go out to all the attendees via GoToWebinar. So we'll take care of that. Question from Chris Rayner. Have you tried using prompting techniques like chain of thought or reflection to get more reliable answers from ChatGPT for coding problems? Yeah, I kind of do stream of consciousness stuff is sort of mostly what I do with it. I guess this thing needed to keep generating more code. I haven't tried using anything like AutoGPT or any of those agent-based programming models because I find they don't work. So I don't really bother with that. But I haven't really tried to do anything sort of formal with any of my generation techniques. A lot of what ChatGPT gives me are mostly the stubs of things I need to kind of work, do my job if I'm writing C# with it. With things like YAML and shell scripts, I can pretty much use whole cloth, some of the suggestions that ChatGPT comes up with. So I kind of like to cherry pick some of the outputs that it gives me. Okay. All right. Well, thank you very much for your time, everybody. I really appreciate it. Thank you for attending as well. We should be sending out a link to the recording about an hour after this airs, and I'll make sure the slides are all available up on our. I'll make sure the slides are all available up on our SlideShare. So thank you very much for your time. I appreciate it, and we'll catch you next time. Thank you very much.